Welcome to today's webinar, Real-Time Data Processing using AWS Lambda. Our presenter today is Cecilia Deng. Cecilia is a software development engineer on the AWS Lambda team, working on the real-time data processing components for the AWS Lambda backend. Cecilia joined AWS from Vancouver, BC over 2 years ago, where she was creating online services for the games industry. Cecilia graduated from the University of British Columbia with a degree in computer science. Today with us, we also have Brian Liston. Brian will be using our moderator today and answering the questions through our Q&A panel as you submit your questions. Cece, welcome. The floor is now yours.
Hi. Today we're going to be talking about Lambda stream processing. We're going to start off with the overview of the AWS Lambda service itself and also Kinesis, and then sort of dive into how they interact with each other, how to set up configuring the event source, and then really into the details of enhancing your processing and making sure everything goes smoothly. So to start off with, I kind of want to talk about Lambda itself. A Lambda function is a piece of code with stateless execution. And another key component of this is the fact that it's triggered by events. These events you can trigger directly with a synchronous or an asynchronous API call. You can do this through the CLI or a Java SDK. Or you can trigger an event through various different AWS service integrations. This can include S3 events or the Kinesis DynamoDB stream events, SNS notifications as well. Various AWS services now allow you to generate an event that can notify a Lambda function, as well as other third-party triggers. So what all this allows you to do is perform data-driven analysis, auditing, notification of data, including real-time data, and also build back-end services, all of this performing at scale. Today we're going to really drive into the real-time data-driven analysis of events generated from a Kinesis stream. Amazon Kinesis is a way to, it allows you to create your real-time processing stream. Reasons why to use it is that it's fully managed, in that it makes it super easy to provision, deploy, manage your stream. It's highly scalable onto your traffic, very durable. Like many other AWS services, your data is replicated across AZs. The data in your stream is replayable up to default 24 hours. There's very low end-to-end latency, so this is what makes it real time. There's no upfront cost like other AWS services. It's all pay as you go, and it makes it very easy to enable all this real-time data movement to various data stores or processing engines. This idea of continuous processing is done through methods such as get sharded data and get records, as well as the ability to checkpoint and replay your data. The other components that does this for you include KCL, which is a public library that you can find online that's generated by the Kinesis team, as well as the Kinesis services Firehose and Analytics, which uses a Kinesis stream on the back end but allows you to help process. As well as those services, we now have Lambda, so you can hook up your Kinesis stream and have it invoke Lambda functions in real time. So that's what we're going to dive into today, the data processing and streaming workflow between Kinesis and Lambda. This also includes DynamoDB streams, and today we're going to give an example for Kinesis. So how it all works for streams and Lambda integration is it's based on my poll event source model, and that's to say Kinesis is mapped as an event source in Lambda. So you use APIs on the Lambda side called add event source mapping or update event source mapping, and through this configuration you create an event source mapping that you can see on the Lambda console, and this tells Lambda to pull that particular stream, batch it into available records, which are then passed for invocation to Lambda through function parameters. So the fleet of pullers is running a flavor of KCL, but we do the processing for you. You don't have to implement this logic yourself, and you don't need any resource policy. All of this is done in your existing Lambda execution role, and we'll dive into what these configuration details mean. The event structure, so this is the payload that's received on the Lambda function from a record on the Kinesis stream. It is kind of looks like this. So this is an example. You can see some details about the Kinesis record itself. You can also see which stream it's coming from and the data that's on the record itself. All of this is done synchronously. So whenever Lambda receives a payload, or the puller receives a payload, we will invoke Lambda in a synchronous blocking request response type. The reason why we do this is to honor the Kinesis at least once semantic. So what this looks like is each shard will block on in-order synchronous invocations of your payloads. Some other sort of how this all works or features is multiple functions can be mapped to one stream, and multiple streams can be mapped to one function. There might be some, the way that it affects each other we'll talk about a little bit later. Each mapping is a unique key pair between the Kinesis stream and to a Lambda function. So you can have multiple to multiple mappings here. I'll do a quick demo on setting up a brand new Lambda function and connecting it with a Kinesis stream. So this is the AWS console. If you're not familiar with it, this one is the one for Lambda. You can go down to Services, drop down, enter Lambda. In order to create a new Lambda function, you can click this button here, and that brings you to the blueprint page. A quick overview of what blueprints are is a predefined set of both code, configuration, including role, and any event sources that you might need. For example, for this demo, I want to create a Lambda function that is triggered by a Kinesis event source. So I'm just going to type in Kinesis. And here we have 3 blueprints already here for us. I'm going to pick this one in Python, and what we'll do is help process the Kinesis. We'll dig into the code in a little bit. So I want to be able to attach this to a stream. So let's also create a new stream here so we can take a look at what that looks like. Here's the Amazon Kinesis dashboard. We talked a little bit about Kinesis Firehose and Kinesis Analytics. Those are 2 services that help you deliver data and stream data with Amazon Kinesis streams as the underlying source, but it will also have some logic to help process it. Here I just want to create a new Amazon Kinesis stream itself, and I'm going to use Lambda to process it. I'm going to call this stream demo. Not very imaginative, I know. And the number of shards here will help you decide what the parallel processing power is for your stream. If you're not sure what you need, we also have this handy little dialog that opens that kind of helps you imagine what sort of throughput you will need, how much read capacity you will need. For the purposes of this demo, I'm just going to create one with 2 shards. And here it is creating. It'll take a couple of seconds for that to finish creating. And here, back on the blueprint side, I'm going to select the blueprint again. And I'm going to choose my newly created demo stream that I just created. Batch size here, I'll go into this also more in depth, but it really is the maximum effective batch size. So this is the maximum limit that you are setting that can possibly be in a payload to Lambda. It doesn't necessarily mean that every invocation will contain 100 records. but it will maximum contain 100 records. Starting position, here we allow two options, trim horizon and latest. Trim horizon will specify that you will start processing the very first or the oldest record in your Kinesis stream, and latest means that I'm going to start processing on the newest record in my stream. And really where this comes handy is, say you enable or disable your stream and you want to pick and choose at what point you want to start processing again. I want to enable this trigger between Kinesis and Lambda, so I'll choose that. Now I'm going to configure my function. I'll also call this Kinesis demo. Here, the blueprint has specified some code for me already. You can see that all it does is print out the payload that I'm going to put into my Kinesis record, and then I'll log it to CloudFormation, which we can, or CloudWatch, which we'll take a look at later. For a role, and if it's not familiar, the handler that you specify here, Lambda function will be the name of the code file that will be zipped up for you and then uploaded to Lambda. And Lambda handler is specifying this method, Lambda handler, telling it which function to start executing from. For role, the console makes it easy for you to make sure you have all the necessary permissions in order to pull from, for Lambda to pull from your stream and then do the things that you want it to do. So say I want to create a new role. I want this console to create a new role for me. I'll call it demo Kinesis role. And here we have some templates on what you think you want your Lambda function to do. And you can always add or remove and edit this later. Since my Lambda function itself doesn't really do much except log some things, I'll just give it some extra CloudFormation permissions. The memory will determine how much processing power the Lambda function itself has, and timeout, I guess it's self-explanatory, how long I want my Lambda function to run before it times out. I don't need VPC access here. My Lambda function isn't doing anything super fancy. So this is reviewing what we're going to do, set up this trigger to my Kinesis stream, and create a Lambda function. So it'll take a while to go through everything. Let's see, the Kinesis stream is active. We'll also take a look at how the console creates the role and writes to CloudWatch. Okay, so everything is fully created. We have the trigger set up. You can see on the Lambda console that you can take a look at your code in line, see the configurations that we just created, see the trigger that we just created, and also some different monitoring metrics. We emit the metric for how many invocations per second, the duration of your Lambda function, how many errors, and how many throttles. So this will all help you monitor your Lambda function. On the IM side, I want to take a look at the role that we just created. And just to show you, this is the permissions that it's created, so you can add logs and also be able to, this is the extra permissions I added for CloudFormation. And here's the one that allows Lambda to list, describe, and basically pull from your stream as well as invoke your Lambda function. So let's test this out. Let's throw some records into the stream that we just created and see that it invokes a Lambda function. So I've already sourced my credentials, and I want to put a record into my stream Kinesis demo, I believe. I'm just going to double check. Oh, my stream demo. And this is just, I'm just going to use the CLI here and give a really sample. And partition key here is also important, and we'll talk about why. You can see using this partition key, I just chose a random string. I have added this record to shard 0 repeated. And if I choose a different partition key, I might write to a second shard. And this is all done through hashes. I guess it's all writing to one. But it's important to be able to define your partition key in such a way that it does hash across your various shards to make sure that you add records evenly across your different shards. So let's see some invocations. So here we can see in the monitoring side that some Lambda functions were fired. And these were fired due to the trigger. I didn't invoke these Lambda functions myself. And to really hammer this home, we can also take a look at our CloudWatch logs and see if it logged the things that I expected it to log. And here you can see we've just added some, logged some tweeting messages. I think this is the latest one. So yeah, this is just like a really quick demo of how to set up a Kinesis stream and a Lambda function, set them up. For production purposes, you will probably use the SDK or CLI and and instead of using a command line, throw way more records. Lambda will scale for your needs. By default, you have 100 concurrent executions. And if you need more, you can also increase that limit. So let's dive in deeper into what all of this means. Okay, so to go over what we just did in the demo, when you create a Kinesis stream, you specify how many shards you want. It's important to know the limitations of each shard so you know how many shards you need. And that is each shard supports writes up to 1 megabyte per second, and they support reads up to 2 megabytes per second. There's also the limit of 5 transactions per second. This is control plane actions. So if you are calling get records on one stream, there's a maximum of 5 get records per second. All the data in your stream is stored and replayable for up to 24 hours. If you were processing through your stream and say you wanted to start from the beginning again or a different checkpoint, for the Lambda event source, you can disable your stream, and if your configuration is at trim horizon, you can enable it again and it will reprocess everything from your oldest record in your stream. So that's sort of what the replayability allows you to do. The partition key is supplied by the producer, so in the demo, it was me on the command line, and it's used to distribute the put records across your different shards. And I didn't do that good of a job, but in your production environment, you would want to sort of be careful on what you set as that partition key. A unique sequence number is returned to the producer upon a successful put call, and that will help you checkpoint through the stream. That's what we use in order to sequentially move through the stream. Yeah, so that's the details on creating this Kinesis stream. When we were creating the Lambda function, the configurations that we looked at were memory. So CPU and disk will be proportional to the amount of memory that you're configured. So increasing the amount of memory will also increase the amount of CPU and disk space that is allowed for your Lambda function execution. If you were seeing that your Lambda function was taking longer to process, for example, with bigger batches of records, it might be memory or CPU bound, and a way to test that is to increase the amount of memory and see if that reduces the amount of time it takes to execute your Lambda function. The timeout will increase the timeout allowed for your Lambda execution. So this is a good configuration to increase if you were also starting to see larger batches of records, for example. It does also mean, though, that if there were errors, you would wait longer to see those errors return back to you. If it was the type of error that doesn't stop your Lambda function, for example. For retries, for Kinesis streams or DynamoDB streams, Lambda will retry the record until it expires. So by default, all records will live for up to 24 hours for 24 hours in your stream. So that means a newly created record, Lambda will retry that record for 24 hours. And because this is a synchronous execution model, we will block all processing on that stream until the record is done, is expired. So this directly impacts processing of your stream. For permission model, the execution rule defined for Lambda must have permission to access the stream. And we kind of showed that in the console demo what that permission looks like. The console will create it for you if there were any clarifications required. When you configure the event source itself, you can define the batch size. And this is the maximum number of records that Lambda will send in one invocation. It's not equivalent to the number of records Lambda will pull from Kinesis, nor is it equivalent to the amount of records that will be in one Lambda execution. So the effective batch size that's in an actual execution is the minimum of records available when we call get records from Kinesis, the batch size that you configured, and there's also another limit of the payload size that we send in one synchronous invocation. Currently that is 6 megabytes. If we don't get any records, we pull from Kinesis every 250 milliseconds. Increasing the batch size will allow fewer invocations, possibly when there is high throughput on your stream. But it also means that more data will be processed in each invocation. So this is a trend that you will see when you have higher throughput on your stream and you've increased the batch size. You will see that each invocation is processing larger number of records, but the rate of invocations may decrease. The starting position here between trim horizon and latest tells you where Lambda will start reading. Starting it at trim horizon, we'll start reading it from the start of the stream, so it will process all data, and setting it to latest will read the most recent data. So now we'll dig into the details of how Lambda will process from your stream. Really to hammer home the idea that all of this is per shard. So all processing throughput here that we'll be describing will be per shard. All the logic is per shard. Lambda calls get records per shard with a max limit from Kinesis. So Kinesis will allow you to have 10K records or 10 megabytes of records in one get record payload. If we call get records and we don't see any records, we will wait 250 milliseconds before we call get records again. When we do get records from Kinesis, we store this in memory, and with this in-memory batch of records, we will then sub-batch to honor the other limits, such as the batch size that you guys have configured, as well as format the records into the Lambda payload, into the format I had shown previously. And each of these invocations will be a synchronous invoke. So our Lambda puller, where all this logic lives that will be pulling each Kinesis shard, will wait for the synchronous invocation of this sub-batch of records before it will take the next sub-batch and then invoke again. So because Lambda blocks on order processing for each individual shard, it really limits the parallel processing on your Kinesis stream. This is why increasing the number of shards itself, given with even distribution across the shards, this will allow increased concurrency. So this will allow the increased throughput processing of your Kinesis stream. If you don't have enough shards, you will only, the number of, or the throughput will be limited. Batch size may impact the duration of the Lambda function as well. So this does impact processing because we block on the synchronous invocation to return, the duration of the Lambda function directly impacts the throughput as well. So a way to sort of visualize this in your head is the maximum theoretical throughput is kind of around the number of shards times the 2 megabytes Kinesis stream limit of how fast we can read per second. So if you have a stream and you have X number of shards, the maximum that we can pull messages and process them is the number of shards times 2 megabytes per second. The effective theoretical throughput will, and this is coming from the Lambda polar, will be the number of shards times the effective batch size. This is the number of records that the polar has sub-batched in the invocation, divided by how long it takes to invoke your Lambda function. So given this sort of fuzzy calculations, you can kind of see if your input or ingestion rate is greater than your theoretical throughput, then your processing is probably going to need a little bit more tweaking. It will be at risk of not keeping up with your stream. Some common observations we've seen around this is that the effective batch size is generally or may be less than configured during low throughput. So even if you've configured your batch size to be 100, when you do not have many records in your stream, you will see a smaller effective batch size in your logs, or that you will see processed in a Lambda execution. The effective batch size will increase when you have higher throughput on your stream, and this is because the Lambda polar will be grabbing more records in each get record call. The number of invokes and get record calls that you will see in your metrics will decrease when the Lambda function duration increases. And this is part of the blocked synchronous behavior. When the Lambda function waits for a Lambda execution to return, it will also not be invoking and calling get record APIs. So you will see those metrics also decrease in that case. In terms of errors, when the Lambda polar sees errors, we do retry the failures until the records is expired. There is exponential backoff and jitter in these retries. But what this really means is that any throttles and errors seen during the Lambda execution directly impacts duration and throughput of your Kinesis processing. If you are seeing problems with your Kinesis stream, one of the first things to look at is whether your Lambda function is suffering from any errors or throttles, and to really address those first. So to update the theoretical throughput calculations, it will be the number of shards times the effective batch size divided by the function duration and also any retries until the record expires. Let's get into how we can monitor how the processing is doing. Kinesis provides some metrics here. One of them is the get records, and this will help you determine what your effective throughput is from the Lambda processing. So you can see this in bytes, latencies, number of records. You can also see the put record metric on the Kinesis side, and this will tell you what how much the ingestion rate is. And you generally, if the get records rate is much lower than put records, you will have to. That indicates to you that you may not be keeping up with your stream. This is also a little bit more obviously seen on the iterator age milliseconds. And here is a graphic of what that looks like. So what the get records.iterator age milliseconds metric tells you is how old your last process record was, as seen by the Lambda polar. If it's high, that means processing is falling behind, because the last record that we just processed was old. If that last process record was close to 24 hours and you still have your 24-hour default lifetime limit of records, then it does mean that your records are close to being dropped and not being processed. On the Lambda side, we have metrics on invocation count. So this can tell you what TPS is like. The duration of your Lambda function, looking at the average and about this will give you an idea of if Lambda execution is reacting maybe to your batch size. The error count and throttle count, and these are probably handy metrics to alarm on in production. And if you see any errors or throttles, you can know it is affecting the processing of your Kinesis stream. To help you debug all this, we add logs in the CloudWatch logs. You can also add custom logs through your Lambda function and see the amount of memory consumed and search through various different log events that you would like. So kind of wrapping things, the best practices here include creating enough shards for parallel processing and also evenly distributing load across your shards, making sure that you're really taking advantage of all the parallel processing power that is given to you by having these shards. Monitoring and addressing any Lambda errors or any Lambda throttles, as well as monitoring Kinesis limits and throttles. It's also good practice to create different Lambda functions for different tasks that you would like to do. This is along the microservice paradigm and not having various different groups of logic in one Lambda function. And yeah, your next steps, you can create your first Kinesis stream, create and test your first Lambda function, use blueprints to help tie them together and start playing around with those services. We also have various developer guides and GitHub examples. Thanks. I'll leave this page with the links in case anybody would like. Oh, and also, if you're interested in learning more, you can join us on our upcoming Dev Day in Austin on October 24th for a free one-day developer event featuring tracks, labs, and workshops around serverless, containers, IoT, and mobile. Yeah, for any additional information, you can register at a link that we will provide below. It's in the Q&A. Okay.
All right, well, thank you, CC. Thanks for the great presentation. And Brian, thanks for engaging our audience with the questions in the Q&A. On your screen, you'll see 3 live polls on the left side. Please provide us your feedback by clicking the radio buttons next to the reply for each poll there. We have actually I have quite a bit of time left, so we have time for our questions today. So keep submitting them in the Q&A panel at the top of the screen. We do appreciate that. We'll start addressing some of those. So let's go ahead and go into our Q&A portion.
So, let's see. So there's not, I wouldn't say that there's like a way to guarantee it, because the first concern that we're trying to do here is process things as efficiently and as fast as possible, rather than having a certain amount of batch size. Because if you specified a batch size and we didn't find that many records in your stream, it means that we'll wait longer in order to grab that many records. In general, we recommend that you design your system to allow duplication of execution of a record, because it may happen, especially during retries. I'm not sure if that answers the question. I guess it's not really. We don't really have a way to guarantee the consistent batch sizes. The next question is, can we configure the number of retries for a unique DynamoDB or Kinesis stream record in case of a failure or exception? So today we don't allow a configuration. I don't know if you want to speak to data plans. No. Yeah, so there's no way to do that today. Another question is the polling process considered one Kinesis consumer when there are multiple functions on the same stream? Okay, so no. The one event source mapping is the unique relationship between a Kinesis stream ARN and the Lambda function ARN. So if you have multiple functions or different functions on the same stream, what that means is that they're actually different unique event source mappings, and each unique event source mapping will have their own iterator, and so they all might be processing at different points in the stream. They will all have their own sort of processing iteration. Next is there a way to make the Lambda poller poll a Kinesis stream in a different AWS account than the one Lambda is running in? So while the Lambda function itself can talk to different resources across different regions, the polling of the Kinesis stream currently must be in the same region as the Lambda function that we're trying to execute. Yeah. So those are the ones I see right now. Yeah. One way you can maybe get around this is to have the Kinesis stream go to a Lambda function in the same region, and then have that Lambda function distribute work to other Lambda functions in different regions. Because you can have Lambda functions invoke Lambda functions in other regions and use resource policies and IAMs to allow permissions across different accounts as well. Okay, the next question, can Lambda pull a Kinesis from another account? Oh, so this is a similar question. The answer is, again, right now, the best way we recommend to do something like this is to have a Kinesis connected to the same account in the same region, and then have the Lambda function on that same account, on that same region, own any logic, any cross-account or cross-region logic. Yeah. I think before we've also talked about having multiple functions on a stream, whether they would interfere with processing. So going back to Kinesis limits, I don't know if you can still see the map. Okay. So really this is a factor of the limits on the Kinesis stream itself. In this case, likely the read of up to 2 megabytes per second and 5 transactions per second. So if your stream has relatively low activity, having more Lambda functions configured as event sources may not interfere with each other as much because they won't hit altogether the 2 megabytes per second or 5 transactions per second limit. However, if you do have a lot of records in your stream and we're pulling as fast as we can and Lambda functions durations are relatively short, you might see processing for some of the Lambda functions start to hit these limits, and it will impact a Lambda function when these limits are hit, or the processing when these limits are hit. Any other questions? Okay, so I think we don't have any more questions, so we'll just wrap it up here and leave it on the last slide for any links that you like. Thank you for listening, and I hope you found this useful.
At this time, I'd like to spend a special thank you over to Cece for her time and the great presentation. And Brian, thanks for answering all the questions through the Q&A panel there, and to our other moderators that have helped out throughout the session. If you have any comments on our previous or upcoming webinars or suggestions on the topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. Thank you to the audience today for spending time with us. Everybody have a great day, and this will conclude our session.